Hello everyone and welcome to Classico Academy. Today we are going to study gravitation and the value of G as well as the variation on the value of G and the factors affecting the value of G. So basically we all know what gravitation is. It is the force with which two bodies attract each other, or two bodies having certain masses attract each other. Okay, and we all know the most basic thing regarding gravitation is that the Newton's law, that Newton said that the bodies having masses m1 and m2, the force acting between the bodies is directly proportional and inversely proportional to the square of the distance between them, and therefore F came out to be G times m1 m2 upon r square, where G is a universal gravitational constant having a value 6.67 into 10 to the power 11 Newton meter square upon kg square. Okay, and this formula is quite similar to the Coulombic force between the two charges. F is equal to k q1 q2 upon r square. We have studied that. Okay, so now let us consider the earth. Okay, and there is a mass or a body or a person on the surface of the earth. What force is what force does the earth exerts on this person? It is mg, and according to gravitational law, Newton's gravitational law, this force is equal to G times mass of this earth and mass of the person upon re square. Why? Because re is the distance between the center of the earth and this person. Okay, so Gme into m upon re square should be equal to mg, isn't it? ये mg क्या है? mg वही फोर्स है जिससे कि अर्थ उसको अट्रैक्ट कर रही है, और दोनों बॉडी के बीच का जो अट्रैक्शन फोर्स है वो Gme m अपॉन re स्क्वायर होगा. ओके, re स्क्वायर क्यों? ठीक है, इसके सेंटर ऑफ मास का भी कुछ हाइट होगी, बट देन दिस इज नेग्लिजिबल एज कंपेयर टू द रेडियस ऑफ द अर्थ. ओके, अब नाउ m से m कैंसिल, सो Gme इज इक्वल टू Gre स्क्वायर. This particular thing is going to be used in the entire derivations of gravitation. मतलब जितने भी derivations हम gravitational potential की करेंगे या gravitational field की करेंगे वहाँ पर भी, या variation in acceleration due to gravity की करेंगे, या numericals में जब भी, ये बहुत काम का फॉर्मूला होगा. Gme is equal to Gre स्क्वायर, और यहीं से हम G की वैल्यू भी कैलकुलेट कर सकते हैं. सो G is equal to Gme अपॉन re स्क्वायर, Gme अपॉन re स्क्वायर. Okay, so this capital G is 6.67 into 10 to the power minus 11 Newton meter square upon kg square. Mass of earth is 6 into 10 to the power 24 kg and radius of earth is 6400 kilometer. So on putting all these values we get G is equal to 9.8 meters per second square. Okay, and we normally use 10 meters per second square as the value of G for the sake of ease. Okay, for the sake of ease in calculation, आसानी से calculation हो जाए. Okay, द थिंग इज कि ये कैपिटल जी तो कांस्टेंट है, दिस इज यूनिवर्सल ग्रेविटेशनल कांस्टेंट. आप यहाँ रहो, चांद पर रहो, किसी प्लेनेट पर रहो, पूरी यूनिवर्स में दिस जी इज कांस्टेंट, बट दिस जी इज नॉट कांस्टेंट. ओके, व्हाई इज दिस जी नॉट कांस्टेंट? बिकॉज विद द एल्टीट्यूड इट इज गोइंग टू वैरी, विद डेप्थ इट इज गोइंग टू वैरी, एंड एट द सेंटर ऑफ द अर्थ दिस re becomes 0, the radius of the earth this becomes 0 when we are going at calculating the force of gravitation at the center. So this G keeps on changing. Now on what factors does that G depends? Let us see. The first and the foremost factor on which this small g depends is altitude. मतलब अर्थ के सरफेस से हम कितने ऊपर जा रहे हैं और ऊपर जाने से G में क्या वेरिएशन हो रहा है वो हम देखना चाह रहे हैं. Now the various factors is altitude or height. Second thing is depth. अर्थ के अंदर कितना डिग इन कर रहे हैं हम. And the third factor is a rotation of the earth. Rotation of the earth. Okay, these two derivations are quite similar. And rotation of the earth में हम थोड़ा centrifugal force की help लेंगे, and we'll try to detect, we'll try to find कि on pole what are the values, या rotation से pole पर क्या effect होता है या equator पे क्या effect होता है. Okay, so that we'll be doing on later part. Right now we are going to do dependence on altitude. Okay, so let us consider this is the earth, this is center of the earth, and a person here or an object is here at a height let's say h from the surface of the earth, and this is of course re, radius of the earth. So this distance, let's say r, so r is equal to h plus re. Okay, इतनी चीज clear है. Now as I said, the value of acceleration due to gravity g is g here, but then once the person is at a significant height from the surface of the earth, this g is no longer g. अब ये g change करेगी, अब ये g वो नहीं रहा. Now let's say this is g dash here. Okay, so we are trying to calculate the force acting on this body at this point. अब ये g dash है, तो now earth is pulling this particular body with a force mg dash towards its center. Okay, and distance is what? According to Newton's law of gravitation, the force is going to be g times capital G, mass of earth, mass of body, upon this distance r ka square, r square. So mg dash is equal to gme into m, and for r we can write h plus re. So h plus re whole square. Okay, so m से m cancel हो गया, g dash is equal to gme upon h plus re whole square. I guess this is clear up to this. Now we have seen कि बस जब surface पर थे तो एक force mg थी, and this force mg was equal to gme into m upon re square. फिर हमने m से m cancel किया था and then we said कि gme is equal to gre square, cross multiplication. Okay, so gme is equal to gre square. So we are going to put this gme equal to gre square here. So now g dash is equal to gme के जगह पर gre square रख दे, and now this is h plus re whole square. Okay, so now this g dash is equal to, this can be written in another way as g dash is equal to g times re plus h. Now this is a square, again this is also a square. So when I try to bring it in the denominator, it will be somewhat like this. ये इसका स्क्वायर हो जाएगा. ओके, और इसको अगर अच्छे से लिखे तो g dash is equal to g times re plus h upon re का पावर -2. ओके, और g dash is equal to g times 1 plus h upon re to the power -2. Okay, this is clear up to this. अच्छा, binomial theorem में we have studied one thing कि if there is such a statement कि 1 plus x to the power n is there, it was written as 1 plus nx, but there was a condition over it. There was a condition associated with it. The condition was कि if this x is very much less than 1, then only 1 plus x to the power n can be written as 1 plus nx. Okay, so now we have g dash is equal to g times 1 plus h upon re to the power -2. Now we are trying to write it in the similar fashion. तो क्या करें? See, this h is very much less than re. We are not talking about कि h is comparable with re. H is very much less than re. So of course h upon re will be very much less than 1, isn't it? So now we are doing what? We are doing g dash is equal to g times 1 plus, see, -2, 1 plus x to the power n is equal to 1 plus nx. तो ये जो पावर था n आकर के x में मल्टीप्लाई हो गया था, तो ये पावर -2 आकर के इसमें जब मल्टीप्लाई होगा, दिस इज गोइंग टू बी 1 minus 2h upon re. So this is the value of g, और acceleration due to gravity, g बोलना सही नहीं होगा. This is the value of acceleration due to gravity at a height h which is very much less than re. ये चीज़ मेंशन करना ज़रूरी है कि this h is very much less than re, or else we are not going to implement this particular binomial formula. Okay, so this was one factor on which the variation in g depends. We have another two factors, that is depth, मतलब डेप्थ के साथ g कैसा वेरी करेगा, एक्सेलरेशन ड्यू टू ग्रेविटी, एंड द थर्ड फैक्टर इज रोटेशन. सो दिस वाज ऑल इन दिस पर्टिकुलर वीडियो. इन द नेक्स्ट वीडियो वी विल बी लुकिंग एट द वेरिएशन इन g ड्यू टू डेप्थ. थैंक यू.